Okay, in this video, we're going to finish up section 7.2, where I left off last time in class. This part deals with solving two linear equations using the substitution method. If you recall, last time we did talk about the intersection method, where we had to draw two lines on a coordinate plane, and you had to find out the point of intersection. And that point of intersection represents the solution to that system of linear equations in two variables. Unfortunately for that, using the intersection method or graphing two lines on a coordinate plane is not the best way, because you're not going to be able to get the exact ordered pair. And sometimes that ordered pair could be in the form of a fraction. So we have two methods that we can use. One of them we'll talk about is the substitution method. The other one is the elimination method. We'll talk about that a little bit later in this video. All right, the main idea behind the substitution method is to use substitution to turn a pair of equations into a single equation with one variable. A simpler problem that we already know how to solve. Okay, so once the value for the variable has been determined, we can solve an additional one or two step equation to obtain the value of the other variable. Okay, so actually we're going to be finding the x value and the y value, which is actually going to be the ordered pair for that system of equations that satisfy that system. So like in this example here, let's say we want to solve the system of two linear equations using the substitution method. Here we got negative 2x plus 4y is equal to 14, and 4x minus 6y is equal to negative 14. Okay, now I'm going to scroll down a bit, because as you're going to see here, this is the equation that we have. Okay, this is just how we solve this equation. And let me see if I can try to do this. Okay, here we go. Since neither equation is solved for either x or y, what I did here was took the first equation, negative 2x plus 4y is equal to 14, and solved this equation. Pretty much I solved it for x, because I see the coefficient of x is a 2 right here. And 4 and 14 are multiples of 2, so let's go ahead and get the negative 2x by itself. I'm adding 4y, so I need to subtract 4y on both sides. So that way I have negative 2x is equal to negative 4y plus 14. And then to get x by itself, I'm multiplying by negative 2. So what I did here is divide each and every term in that equation by negative 2. And this will give me x by itself, and that's equal to negative 4y divided by negative 2 will be a positive 2y, and then plus 14 divided by negative 2 will be a minus 7. So I have the equation solved for x, which is x is equal to 2y minus 7. Now here is where the substitution comes in. The other equation that I have is the 4x minus 6y is equal to negative 4. So here's what I did. I took x equal to 2y minus 7 and substituted for x in that second equation. That way I will have an equation in one variable. So here, substituting the x with 2y minus 7, you'll get 4 times the quantity 2y minus 7, and then minus 6y is equal to negative 4. Now here I use a distributive property. What I did was I distributed the 4 over the 2y minus 7 through multiplication. So 4 times 2y gives me 8y, and then 4 times minus 7 gives me minus 28. And then bring down the minus 6y equal negative 4. Now, from this line, I can go ahead and combine like terms here. 8y minus 6y gives me 2y. So this will be 2y minus 28 is equal to negative 4. And then next, add 28 to both sides to get 2y by itself. So that means I'm going to have 2y is equal to 24. And then divide both sides by 2 to get y is equal to 12. So I know what y is equal to. That's equal to 12. I need to know what x is equal to, because when you're solving a system of linear equation, you want to know what x is equal to and what y is equal to. I know what y is equal to. It's 12. Now we need to find out what x is equal to. In this case here, I get x is equal to 2y minus 7. Let's use that, because since x is by itself, which is what I have right here, and then I substituted the y with 12. So I get x is equal to 2 times 12 minus 7. And then 2 times 12 gives me 24. 24 minus 7 will give me 17. So x is equal to 17 and y is equal to 12. Now, here I did the check to indicate or to show that x equals 17 and y equals 12 represent the solution to that system of equation. So here I took each equation, substituted each x with 17 and each y with 12. So like for negative 2x plus 4y is equal to 14. I substitute the x with 17, substitute the y with 12. So it'll be negative 2 times 17 plus 4 times 12. I want to know if that's equal to 14. Well, negative 2 times 17 will be negative 34. And then 4 times 12 will be 48. So if I add 48 to the negative 34, I would get 14. So the left side does equal to the right side for that first equation. But what about the second equation? 4x minus 6y is equal to negative 4. So here, substitute x with 17. I got 4 times 17 minus 6 times, replace the y with 12. So that's 6 times 12 equal negative 4. Multiply 4 times 17, that's 68. Minus 6 times 12, that's 72. That should equal negative 4. Let's do 68 minus 72. That does give us negative 4 as well. So here, this ordered pair does satisfy both equations. So we can say that the solution would be this: x equals 17, y is equal to 12. Or we can write this as an ordered pair: negative 17, comma 12. Okay. Here's a couple of problems here that are in your textbook on page 395, problems 40 and 42. Here we're going to solve the system of equations using the substitution method. So in problem number 40, we've got 2x minus y is equal to 1, and 3x plus 4y is equal to 29. And then number 42 would be 3x minus 2y is equal to 11, and x plus 5y is equal to 15. Okay, so now let's start with number 40. Okay. Okay. I was trying to. Okay. There we go. Excuse me for that. I was just trying to get this so that you all can see this. All right, start with number 40. You got 2x minus y is equal to 1. And then I wrote to the side the 3x plus 4y is equal to 29. What I want to do is work with the equation that has a coefficient of 1 for either the x or for the y. And this 2x minus y is equal to 1. I'll try to get y by itself, because that y has an understood coefficient of 1. And this is what I did. To get that minus y by itself, I had to subtract 2x on both sides. And when I did that, I have negative y is equal to, and here I put the negative 2x in front, and then plus 1 since it's a positive 1. But I still got that negative in front of that y. To get rid of that, I had to divide each and every term in that equation by negative 1. So here, negative y divided by negative 1 gives me positive y, and that's equal to negative 2x divided by negative 1 would be 2x. And then the plus 1 divided by negative 1 would be minus 1. So here we got y is equal to 2x minus 1. Now, the other equation is 3x plus 4y is equal to 29. Since y is equal to 2x minus 1, I can go ahead and use the substitution method by substituting the y with that 2x minus 1, because that's what y is equal to in this case. So here I have 3x and then plus 4 times, and that y is substituted with 2x minus 1. Notice it's in parentheses. And then that's going to be equal to 29. Now I can simplify the left-hand side. So I bring down the 3x and distribute the 4 over the 2x minus 1 through multiplication. So here I get 4 times 2x, that's 8x. And then 4 times minus 1 will be minus 4. So I get 3x plus 8x minus 4 equal to 29. Now to combine like terms, I have 3x and 8x. I can add those two. That would give me 11x. Then minus 4 is equal to 29. Now to get 11x by itself, I'm going to add 4 to both sides of this equation. To get 11x is equal to 33. And then divide both sides by 11 to get x is equal to 3. All right. Now, since I know what x is equal to, I can go ahead and find out what y is equal to. And I'm going to use y is equal to 2x minus 1 since I've already got y by itself. Because I can directly get what y is equal to by just simply substituting the x with 3 in y equal to 2x minus 1. So I got y is equal to 2 times that x is replaced with 3 and then minus 1. Now 2 times 3 will be 6, then 6 minus 1 will be 5. So y is equal to 5 and x is equal to 3. Now we can do the check if we like by replacing using the original system. Substitute the x with 3, substitute the y with 5. So for 2x minus 1, 2x minus y equals to 1. Substitute the x with 3, I get 2 times 3. Then minus the y substituted with 5. I want to know if that's equal to 1. Well, 2 times 3 is 6, and then 6 minus 5 does equal to 1. So that checks for the first equation. And now for the second equation, 3x plus 4y equal to 29. Again, substitute your x with 3 and the y with 5. You'll have 3 times 3 plus 4 times 5. I want to know if that's equal to 29. Well, 3 times 3 is 9 plus 4 times 5 will be 20. 9 plus 20 is 29. And that checks. So here, the solution for that system in problem number 40 will be x equal 3 and y is equal to 5. Or we can write that as an ordered pair, 3, 5, where x is the first coordinate, the y is the second. All right, now number 42. Here we got 3x minus 2y is equal to 11 and x plus 5y is equal to 15. In this case, I'm going to work with the equation that does have a coefficient of 1 for either the x or the y. And I'm going to start with this one. X plus 5y is equal to 15. And that's because the x has an understood coefficient of 1. And I can easily get x by itself by subtracting 5y on both sides. So that would give me x is equal to negative 5y plus 15. And now this is where I can use the substitution. My other equation is that 3x minus 2y is equal to 11. Here I can substitute that x in that equation with negative 5y plus 15, as you can see here. So here I'm going to have 3 times, and in parentheses, that x is substituted with negative 5y plus 15. And then minus 2y equals 11. Now distribute the 3 over the negative 5y plus 15. You'll have negative 3 times negative 5y, that's negative 15y, plus 3 times 15, which is 45. Bring down the minus 2y, that's equal to 11. Combine like terms, negative 15y minus 2y, that's negative 17y, plus 45 equals 11. And now to get negative 17y by itself, we're going to subtract 45 on both sides. And that would give us negative 17y, and that's equal to negative 34. Divide both sides by negative 17, you'll end up with y is equal to 2. We only know y is equal to 2, but we need to find out what x is as well. Okay, let's use that x equal negative 5y plus 15 and replace the y with 2. So the x is equal to negative 5 times 2 plus 15. Now negative 5 times 2 will be negative 10. Negative 10 plus 5 will be, negative 10 plus 15 would be 5. So x is equal to 5. Okay. And if you would like, you can do the check for each one of these equations and substitute the x with 5 and y with 2 to see if the left side equals the right side. Like 3x minus 2y is equal to 11. I substitute the x with 5 and the y with 2. You see that it does check for the first equation. The second equation, x plus 5y equal 15. I replace the x with 5 and the y with 2. You see, when you simplify that left side, it does equal to the right side. So the solution for this system of equations would be x equals 5, y equals 2. Or we can write it as an ordered pair, 5, 2. All right, next we'll look at the other method of solving two linear equations. Here we can use what they call the elimination method. Now some textbooks call it the addition or subtraction method, because basically you're going to be adding or subtracting two equations in order to get an equation that's going to be in one variable. Now there are some cases where you may have to multiply either one equation or two equations by some common value in order to eliminate. All right, a solution for two equations can be determined using the elimination method. The main idea is to add or subtract equations to eliminate a variable. The result is a one-step equation, a simpler problem we already know how to solve, or should know how to solve. So like in this example here, we want to use the elimination method to solve the following equations. 4x plus y is equal to 11. And negative 4x minus 6y equals negative 26. And here's what I did. The way I did this is I wrote those two equations on top of each other. Now, automatically, you can see here that 4x and negative 4x are opposites. Okay, so if we were to add those two together, the 4x and negative 4x will be gone. They're eliminated. That's why it's called the elimination method. And we can add the y's together. 1y and a negative 6y gives me negative 5y. And then that's equal to 11 plus negative 26. We can add those constants together on the opposite side. You'll get negative 15. So here we got negative 5y equal negative 15. And then to solve this equation for y, we divide both sides by -5 to get y is equal to 3. All right. Now we know what y is equal to. We need to find out what x is equal to. So in this case, I could use either one of these two equations here. I went ahead and used the first equation since it's easier to solve. The other one has negatives in it. So let's use the 4x plus y is equal to 11. And since y is equal to 3, we can substitute the y with that 3. So we got 4x plus 3 equals to 11. And then to solve for x, we subtract 3 on both sides to get 4x is equal to 8. And then finally divide both sides by 4, you'll get x is equal to 2. So x equals 2 is what we're looking for, and y is equal to 3. We can also check to see if the x and the y values satisfy the original system of equations. And it does, as you can see by the check here. So here x is equal to 2, y is equal to 3. Also, we can write that as an ordered pair, 2, 3. Okay. Let's look at problems 43 and 45 on page 395. Okay. Here we want to solve the system of equations using the elimination method. In problem 43, we got 5x plus 2y is equal to 4, and negative 5x plus 6y equals negative 8. So here's that. Now notice I wrote the two equations on top of each other. Negative 5x plus 2y is equal to 24, and negative 5x plus 6y equals negative 8. As you can see, I can easily eliminate the 5x's because 5x and negative 5x are opposites of each other. So when I add those, they're gone. They're eliminated. I can add 2y and 6y. You'll get 8y. Then that's equal to 24 plus negative 18 would be 16. So I got the equation 8y equals 16. And now to solve this equation for y, we divide both sides by 8. You'll get y is equal to 2. So that's what y is equal to, but I have to find out what x is equal to. Now I can use the first equation or the second equation. I'm going to use the first equation. 5x plus 2y is equal to 24. And I'm going to substitute that y with the 2. So here I got 5x plus 2 times the y substituted with 2 equals to 24. Well, 2 times 2 is 4, so I have 5x plus 4 is equal to 24. And to get 5x by itself, I subtract 4 on both sides to get 5x is equal to 20. And then to get x by itself, we divide both sides by 5 to get x is equal to 4. And again, you can do the check for each one of those if you like. You'll see that they both balance out. So that means that x is equal to 4, y is equal to 2 is the solution to that system of linear equations. We can also write it as an ordered pair of 4, 2. So if you were to graph those two equations on a coordinate plane, then that means that those lines should cross each other at the ordered pair 4, 2. All right, now problem number 45. Here you got 2x minus y is equal to 1 and 3x plus 4y is equal to 21. Now this one is a little bit different. This one's a little bit different, as you can see. Because if I was to add 2x and 3x, I'm going to get 5x. If I add the negative y and the 4y, that would give me 3y. Neither the x nor the y is eliminated. So that's going to mean I'm going to have to multiply either one equation or two equations by some number in order to eliminate either the x or the y. Now, when I start this one off, I eliminated the y because notice I have a minus y and a plus 4y. Now I've already got 4y here, but to make that 1y or 4y, I need to multiply that top equation by 4, as you can see here. So when I multiply 4 times 2x, that's going to give me this 8x. 4 times the minus y would be minus 4y, and that's equal to 4 times 1, which is 4. And then I can bring over that 3x plus 4y is equal to 21. Now I can go ahead and add those two equations together. That way I can eliminate the 4y. They're gone. Now add 8x and 3x, you're going to get 11x. And that's equal to 4 plus 21 will be 25. So I got the equation in one variable, 11x equals 25. And then divide both sides by 11, you'll get x is equal to 25 over 11. Now here I got a not so good number, which is a fraction. Normally, like the other equation, I would substitute the x in either one of these two original equations, but I'm going to be dealing with a whole lot of fractions here. So this is what I did here. I rewrote the original system, which is right here. 2x minus y is equal to 1, and 3x plus 4y is equal to 21. First, I started off by eliminating the y's. This time, I'm going to eliminate the x's. In this case here, I got 2 and a 3 for my x coefficients. I'm trying to find a common multiple for 2 and 3. That is the smallest number that is divisible by 2 and divisible by 3. In this case, is 6. Now, to make that 2x or 3x, a 6x, I need to multiply that top equation by 3. Now for the second equation, I got a 3x. If I want that 3x to be a 6x, I need to multiply the bottom equation by 2. But in order for me to eliminate the x's, since both of them will be positive, one has to be a positive, the other one has to be negative. I made the 3 negative. I could have made the 2 negative if I wanted to, but I went ahead and made that 3 negative. So I'm going to multiply the top equation by negative 3. This is what I would get. Negative 3 times 2x will be negative 6x. Negative 3 times the minus y would be a plus 3y. Negative 3 times the 1 would be negative 3. So I get negative 6x plus 3y equals negative 3. Now for the second equation, I'm multiplying it by 2. So it'll be 2 times 3x, that's 6x. 2 times 4y, which will be 8y. And that's equal to 2 times 21, which will be 42. Now you can see that the negative 6x and positive 6x added together, that gives me 0. They're eliminated. Add 3y and 8y, this will be 11y, equals negative 3 plus 42, which will be 39. So I get 11y is equal to 39. Divide both sides by 11, you get y is equal to 39 over 11. All right, we know what x is, that's 25 over 11. Y is equal to 39 over 11. And I'm not going to bother doing the check on this one. So this is the solution to that system. X equals 25 elevenths and y equals 39 elevenths. Or you can write that as a ordered pair, 25 elevenths, 39 elevenths. Okay. All right, so this concludes the balance of section 7.2 that deals with equations. The homework for that section will be available on WebAssign. So make sure you have that completed, and feel free to email me if you have any questions about this particular section.